Okay, let's look at this question. Consider the graph below. What is the where is the function increasing? Okay, let's look at it clearly. You can see that it's increasing from here to here. That's increasing. Okay, so it started. Let's just erase that. Started from here. That is -8 and 1. So this point, it is -8 and 1. That is increasing. Let's look at another one that's increasing. From here to here, this is decreasing. From here to here, look at this. From here to here, that is increasing. So from -1 to 1, this is 2. From -1 to 2, so from -1 to 2 to this point is 1 and 4. 2, 1 and 4, and that is increasing also. Again, let's look at this one more time. It is increasing from -8 to 1 to this point. What is this point? -6 and 3. 2, -6 and 3. So these are the two increasing intervals. So we can say here f function is increasing on -8 to -6. -8 to -6. This is the point, but this is the interval where it is increasing. And also it is increasing because united from -1 all the way to 1. And this is united -1 and 1. So these are the function that's increasing. The other one, where is f dash less than 0? F dash less than 0 mean decreasing. Where is the function where it is decreasing? Okay, when the function is decreasing, I'm going to delete these. And I'm going to show where it's decreasing now. Decreasing, you can see it is from -6, and this is of course -6 and 3. It's decreasing from here all the way, let's say it is to this point. So -6, and let's take the interval, the x interval, -6 all the way to this point, -6 and -2. So f dash, the function less than 0 on -6 -2 united. Where is also decreasing? From here, which is 1, and all the way to, well, I don't see that this is decreasing, but you could see that it's here. It goes all the way here, all the way, and also there's a change. Well, it's a big, huge decrease. So it is going to 5, let's say 1 to 5. And also united, there's also decreasing here. This is the point of there's this point that we need to take care of. This is 6. So I'm going to make from 6 all the way to the point, this is here 8. Point 8 is going to be not parentheses but something like this to account for the endpoint here. Okay, so if less than 0, which means that the decreasing, here is decreasing, and here is decreasing, and here is decreasing. Okay, that is one part. Where are the critical point is the next one. Where are the critical point of the fx? We should first of all find the derivative of that critical point and make it to 0. Okay, where is that peak and values? Let's delete these. These are the peak values. -6, this is the peak value. This is the local max. So local max, it's at x equal to 6. Local max, x is equal to -6. Okay, there is also a local max at 1 here. This is 1. This is a local max also. A local max at x equal to 1. X equal to 1 here, and this is x equal to -6. Okay, you could also note that the corner points were slope jump. The slope jump here from -1, it jumps, and also it jumps at the 5. You can see here that there is a jump also. It jumps from here. Okay, so they will not touch the 6, but they will jump from the point 5. So where the slope is jumping, it's undefined. So the function, the critical point, the main critical point, x equal to -6, where you have a local maxima, x equal to 1, where you have a local maxima, and the slope undefined corners at x equal, remember, x is equal -1. You see there is discontinuous here. X equal to -1 and x equal to 5. When you have the 5 is not going to go anywhere, and here also the 6 will not go anywhere. So once it starts from the 5, it's not going to even reach the 6. So x equal to 5 is also an undefined corner. Okay, where is the function discontinuous? Okay, discontinuous is very simple. It jump at x equal to -1. We mentioned it. There's a jump here. That's the discontinuity. Okay, at x equal to -1, and of course at x equal to 6. At x equal to 6, there is a big jump. So this is x equal to 6, and that's going to differentiate between this side and this side, and that is the discontinuous. And this is what's left the branch from the field, and the vertical, of course, the vertical asymptote at x equal to 6. So f is discontinue at the jump and at the vertical asymptote at x equal to 6. Okay, let's go for the next one. Does the extreme value theorem apply on the interval -2 to 0? Where is -2 and 0? Well, you can see from -2 to 0, this discontinued, that's not going to applicable because there is no continuity here. There is no continuity. So does this apply? We could say that on -2 to 0, whatever he mentioned here, the graph uses two pieces. And has a jump. And has a jump at x equal to -1. X equal to -1. So it is not continuous because on that closed interval it is not continuous. So the extreme value theorem does not apply here. Identify an inflection point on the graph. So what are the inflection point on the graph? An inflection point where concavity changes on the smooth curve. You can see that there is the left piece of the curve changes on the smooth curve. The left piece switch from concave up to concave down around. Look at that. This is concave. This is concave down, and there is a switch somehow to concave up. That switch, it's approximately at around -3.5, and let's say 0. This is that's the meaning of that. But let's see, is that switch? Well, no, let's look at it. It goes like this. This is still concave down. Still concave down until it might be at this point -3 or -3 and -0.5. So this is where the bend of the first curve change signs change from concave down to concave up. So almost there. It's going to be approximately -3 and 0.5. -3 and 0.5. And that is for this inflection point.